In this topic, we'll look at calendars over the last 2 millennia, leading up to the calendar that we use today, and see what long roots in history our modern calendar has. Calendars are a way of keeping track of time important for every fixed civilization. As we've seen, ancient cultures who were nomadic and did not have fixed abodes and stay in the same place from month to month and year to year essentially kept time with a lunar calendar and then would follow the seasonal cycle, following the food sources as they changed through the seasons. But for the time of civilization, since the Egyptians and Babylonians, so the last 5,000 years, calendars have been important. Let's just look at some of the questions we might ask about our modern calendar, the one we live with all the time. And if you look at this set of questions, I'm going to ask you all to wonder, how many of them can you answer? They're very simple and logical questions about the calendar we use and are familiar with. Why does the day begin on January 1? The orbit of the Earth is a continuous orbit. You could start the year any time you wanted. Why are there 7 days in a week? And where do the names of those days come from? Why are there 24 hours in a day, or 60 minutes in an hour, or even 60 seconds in a minute? These are very different numbers, divisions of time of 24, 60, divisions of time of 7 days in a week. And then when you look at the months of the year, why is February the short month and the only one as short as it is? Why do analog clocks go clockwise? You obviously have a choice. Did someone flip a coin and decide that clocks would go the way they go rather than the other way around? Why do Arab flags, if you've noticed the flags of the world, always include a crescent moon? You should check out some flags of the world and you'll see what I mean. All the Islamic countries have crescent moons built into their flag design. What about special days of the year like Halloween and April Fools? Where did those come from? Are those modern inventions, or have they been around for a long time? And why do you have to go through a strange mnemonic to know the number of days in a particular month? It's not an even pattern, and they're not all the same. And what about those last 4 months of the year, which, if you'll notice a root in Latin, come from the numbers October, November, December. September, October, November, December are all named after numbers, but they end with 10, not with 12, and yet the last one is the 12th month of the year. So where does all that come from? Well, the first part we can see is that the days of the week were named for the sun, the moon, and the visible planets. So these were the obvious objects in the night sky and the daytime sky, the sun, the moon, and the 5 naked eye planets that have been known since antiquity. But if you want to know where the days of the week come from, you actually have to go through a little cultural lineage to recover where they come from. In fact, if you go to a Romance language, or you travel to the countries of France and Spain and Italy and Portugal, then the days more obviously map to the astronomical objects because they reflect the names of those objects. The English days of those names have retained some of those: Sunday after the sun, Monday after the moon, fairly obvious, Saturday after Saturn. But what about the other 4? It turns out the other 4 days of the week in the Western Europe and Northern Europe tradition come from Teutonic myths of almost 1,000 years ago. Tuesday is named for the god Tu, Wednesday for the god of war Woden, and Thor for the god Thursday. Freya, the feminine character for fertility in Norse and Teutonic legend, gives us the name of Friday. So our day names are a merger of astronomical objects and Teutonic myths that we've had for hundreds of years. Our modern calendar has a very interesting history that's worth looking at in detail. Our modern calendar came from the Romans because we have a lineage in the United States and in Western Europe that derives from the Romans. Basically, the first calendar started vaguely sometime in the middle of March because people had to regulate the calendar to keep agriculture, and so you wanted to know when to plant the spring crops. In the depths of winter, there was no planting, and so people in Rome, 7 centuries before Christ, started the year sometime in the middle of March, and they had only 10 months in that year. And that's the reason why the 10th month is called December, because the original calendar only had 10 months. First 2 months were added. By the 6th century BC, the Emperor Pompilius had added 2 short months to the front end of a calendar to make it a little closer to a solar year. 354 days in the Pompilius calendar is actually closer to a round number of lunar cycles. So this culture was still torn between the lunar cycle calendar, which is held by almost all ancient cultures, and a solar cycle calendar, which would match to 365¼ days. Priscus came along and altered the days, and at this point you start to see an alternation between 31 and 29, leading to a year of 355 days. Even numbers were bad luck to the ancient Romans, and so the number of the days in the month generally had to be odd. But on the premise that bad luck has to happen somewhere, February was the bad luck month, and so it was given the shortest number of days and was the only month with an even number of days, indicating bad luck. Now for the Romans it didn't really matter, because the Romans were a militaristic, martial society, and they really only cared about when they could send an army off across the Alps to do a conquest, and that didn't happen until the snows melted sometime in March or April. So I think in February nobody really went anywhere. The Roman calendar only got rationalized with Julius Caesar, and that gives us the name of the Julian calendar, the calendar that we used with really only one modification for the last 2,000 years. Caesar rationalized a calendar to have 365 days, if you add up those numbers, and he added a leap year. So February got one extra day every 4th year to give a mean year of 365¼ days, which quite neatly maps to the length of time it takes from the Earth to go once around the Sun. Thereby you have a solar calendar that can help you run your agriculture. Caesar, of course, had to make some other adjustments, and to make the numbers come out. By this time the obsession over even and odd numbers had gone away. He took the first unnamed month, notice the first 5 months of the year are named after ancient gods, he took the first numbered month, Quintilis, and named it after himself, Julius, July, a very great emperor. And the only adjustment after that came from Augustus, a few emperors later, who, unhappy with the fact that Caesar had his own month, he took the next numbered month, Sextilis, and named it after himself, and hence we have August. So we can see that the egomania of the Roman emperors gave us some of our month names, and their obsession and superstition with even and odd numbers led to the uneven distribution of days in the month, which means we have to memorize a little pattern. So where does this leave us in terms of answering the questions I just posed? Well, we haven't answered all of them. Why does the year begin on January 1? The best evidence is that this was done to appease the pagans. So before the Christian church and before the Roman culture, pagans celebrated the solstices and the equinoxes. And their year really began after the winter solstice, when the days would begin to get longer, the sun would begin to rise higher in the sky, and so they celebrated the return of the sun to higher elevations. Now, when you're observing with an artifact like Stonehenge, it takes a week or so to see that the sun is actually moving back to higher elevations. And so the gap between December 21st, the winter solstice, and January 1st is probably just an observational error, which indicates that's when you can start the year. So the Romans started the year on January 1 to co-opt pagan traditions. We've seen why there are 7 days in the week and where those names come from. The 24 hours in a day goes back even further. It goes back to Egyptian and Babylonian practices of marking out the patterns of the night sky by what are called decans, or timekeeping stars. And there were typically 12 of these bright stars which they memorized and tracked across the sky. So the night sky was divided into 12 sectors, roughly corresponding to an hour, and they followed that with the daytime sky, leading to 24 hours in a day. The division of time into 60 minutes in an hour and 60 seconds in a minute comes from the Babylonians. So this dates back 5,000 years, because the Babylonians used a metric system, not a metric system, but a 60-base system of counting. It also corresponds to the number of degrees in a circle, which is 360, which is a multiple of 60. So we see these timekeeping units are also based in very ancient history. We've seen why February is the bad luck month. Analog clocks going clockwise is a reference to Northern Hemisphere cultures. If you think about the way a clock appears, and you think about the motion of the sun through the northern sky above the celestial equator, you will see that the sun appears to go from left to right in a clockwise direction. And so analog clocks, when they were first made, were simply reflecting sun worship, or the fact that we track the sun in its motion across the sky. The Arabian flags in Muslim countries using a crescent moon is a reflection that even now, such countries use a lunar calendar. That's one of the disconnects between Arab Islamic cultures and Western or Christian cultures, because the Western cultures have done a solar calendar based on sun motion, and the Islamic countries have done a lunar calendar based on direct observations of the moon. And so these calendars are different by about 10 or 12 days per year, and the Arab or Islamic festivals migrate through a solar calendar once every few decades. Halloween is a reflection of the pagan celebration of the midpoints between the summer and winter solstices and the spring and fall equinoxes. And so we have celebration times. May Day is another one of these that relate also to pagan principles. And we've already answered the question of why the months are hard to remember and where the last 4 months came from. So we see that our calendar is an amazing composite of historical artifacts built into our culture and traditions that have been passed down for literally thousands of years. Was there ever a rational calendar? Well, yes, there actually was. So in the French Revolution, after Napoleon came to power, he decided that naming festivals and days and months after pagan gods was very not modern, and in his rational New World culture, he wanted a rational calendar. And so he removed all notion of pagan gods. He named the festival days after agricultural celebrations. He basically made a metric calendar. It was a Julian calendar without the overlay of religion and myth. He even tried for decimal divisions of time, dividing the day, hour, and minute into factors of 10. This calendar lasted while Napoleon reigned supreme, but of course it became out of sync with the rest of Europe that was still following the Julian calendar from the Romans, and it was very quickly got rid of when Napoleon lost power. But that was our one shining attempt at a modern and rational calendar. Let's look at naked eye observations and what you can see in the sky. Constellations are regions of the sky where we see patterns. The constellations are defined by the International Astronomical Union, and the modern set of constellations dates back to 1928. But most of the constellations are ancient. There are 88 in all parts of the sky, and 12 of them around the place where the sun appears to move and the moon, the ecliptic, are called the zodiac or zoo of animal constellations. These are just patterns or asterisms, and people, obviously, through history, have just given names to things and imagined they could see objects or myths or legends and commemorated them, often as an aid to navigation. It wasn't purely for recreation. People used the stars to navigate. Especially in the hot parts of the world, in the desert, you would have to travel at night, and so you'd have to use celestial navigation. Again, you would want to know those patterns in the stars so you could find your way. The constellations come from antiquity. There's evidence that the Great Bear, Ursa Major, dates back thousands of years from Siberian times when bears existed. We actually find the Great Bear constellation referred to by the Egyptians, which is interesting. They must have got it from elsewhere since there were no bears in Egypt at the time. And some of the constellations in the southern hemisphere have of course been named by those cultures that existed there long before Westerners came, such as the Aborigines in Australia. They have their name for all the stars and the constellations. But the modern Western-oriented constellations were named typically by European explorers in the 17th and 18th century. It's important to realize that the patterns of stars in constellations really have no physical significance because we just see them on the plane of the sky. And as this little cartoon shows, the stars that seem to be close together in the sky may, in the third dimension of depth, be at quite different distances. And in fact, they are at different distances. So the stars, for example, in the Big and Little Dipper are close to each other in the sky, but very, very far from each other in space because those stars are light years apart in distance from the Earth. But as a mnemonic and as a way of navigation, they're very useful. And so their traditional use now as navigation aids is not relevant because we have GPS, we have modern navigation devices. But they're useful for memorizing the sky, and amateur astronomers still remember them, and most professional astronomers like to navigate the sky too that way. The celestial sphere is the artifact we think about. It appears to us on the Earth that the sky looks like a dome, a hemisphere that moves over our heads, and the stars appear to rotate over our heads, and the sun, of course, appears to rotate over our head, and the moon. All objects seem to move around us. That's our perception. And so in astronomy and in useful terms, we have the concept of the celestial sphere, an imaginary dome or sphere far from us onto which are painted the stars of the night sky. It's a two-dimensional representation, of course, of objects that we now know to be distributed deeply in three-dimensional space, and we now, of course, have measured the distance to these objects. Because it's our view from the Earth, we place the Earth at the center of this sphere. So as you can see, this is a very pre-Copernican view of the sky, but it's still useful operationally for astronomy. And so we can define three planes in the celestial sphere. There's the celestial equator, which is defined by the Earth's rotation, and it's essentially the projection of the Earth's equator out into space. There's the ecliptic, which is the Earth's orbit of the sun, and that's essentially the line defined by the path that the sun takes through the sky, which is also close to the path that the moon takes, since they're in almost the same plane. And finally, there's a third dimension or plane, which is the Milky Way. Not quite as obvious in the northern skies in the southern hemisphere, but the Milky Way spans the entire sky, top and bottom, 360 degrees, and it defines yet another orientation or another coordinate system. So to review, the celestial sphere is the projection into the sky where the stars appear. The ecliptic is the apparent path of the sun, and as the Earth goes around the sun in 365 days, the sun's angle with respect to any horizon at any point in the Earth changes, because the Earth's tilt as it spins is 23.5 degrees from the orbit around the sun. And you can see that angle here between the green and the white lines. And this is how we keep track of time using the stars. You can measure angles in the sky too. It's useful to do so, and you don't need a sophisticated measuring device. These are examples of how you can use your outstretched hands and your fingers to measure angles in degrees fairly accurately. It's good enough to find your way around the sky and learn astronomical observing, to hop the constellations, to find deep sky objects. It's a very useful skill. And that's the end of this topic.